In this session we are going to see the continuation of the previous session. It is part 2 of Simscape Onramp course. In the previous session we have seen two categories. One is course overview along with its subcategories, and then second one is building Simscape models category along with its subcategories. Now we are continuing the third category, that is exploring results. Okay, for this just click on this measuring physical quantities, which is a video. Just maximize it. If you want to skip it, you can skip, or you can go through the video which describes the complete overview of this category as well as the each component functionality along with its importance in this particular simulation. Everything has been described in this video. If you want, you can watch, or just click on next. Once you click on next, it will direct you to the task. Here there are three subcategories. Okay, first one is video, second one is sensor blocks, this across variable, another one is through variable. Now we are focusing on across variable. Just we will be directly complete the task. That is, here we have to add voltage sensor by following this that is library path. You can just search voltage sensor by using your mouse left click. That is, just click on the empty space and type voltage sensor. That should be under foundation library. Just bring this to this side. Fit to view. This button is for to make the circuit fit to view. To rotate the particular element, you can use Ctrl R. Okay, you can use Ctrl R for rotate any element, or Ctrl I for flip the element. You can use, and you have to connect the positive port of this sensor to the capacitor positive and negative port of the sensor to the capacitor negative. This is the task. Now you have submitted and it is correct. And next task. Now you have to add PS to Simulink converter. It is PS to Simulink converter. That should be under Simscape bar utilities. This one you have to connect, and this is the task. That is, we have connected the output of the voltage sensor to the input of the PS to Simulink converter, and submit, correct. And then next task. Now you have to add a scope not to display the results. That is, search it as scope, which is Simulink bar sync, under the category Simulink bar sync, and you have to connect it to the output of the PS to Simulink converter. Now you can submit. It is correct. And then next task. That is, by default the voltage sensor blocks outputs a value within with the unit of volt. Okay, here it is mentioned as volt, but now we need to change the particular one to millivolt. Okay, by typing the small m capital V in the output signal unit field of PS to Simulink converter. Just open the PS to Simulink converter where you have the output signal unit. Okay, in this parameter setting you have the output signal unit where it is mentioned as inherit. Okay, just remove the inherit and type it as small m capital V and then close. Now submit. And then, which is correct. And then next task, and then next section. This is about across variable, and next we will be directing to the through variables. Okay, this is through variable. First we have completed the across variable, next is through variable. Now here we have to add current sensor. the current sensor we have to add under foundation library, and you have to delete the connection between the resistor and capacitor in order to make the current sensor to connect in series with the, it is in between the resistor and capacitor. Okay, therefore I have to place it like this. Connected the negative port of resistor to the positive port of current sensor, and negative port of current sensor to the positive port of capacitor. Like this I have to connect, and this is over. Submit. It is correct. Next task. Now you have to connect the current sensor to the scope block using PS to Simulink. So I have to include PS to Simulink converter block, and then I have to include scope. Both I have to connect in series like this. Now submit, and it is correct. In the next task, now you have to disconnect the current sensor block from the circuit and reconnect it in the opposite orientation. That is, the positive negative should be changed. Okay, so I have to disconnect both the connection from the resistor as well as capacitor to the current sensor. Now I have to rotate. Okay, you can rotate, or you can just right click on the particular element, current sensor. After right clicking, you have to go to format and then rotate clockwise. Once again do the same procedure, format, rotate clockwise. It will be rotated. Now you can connect this negative to the resistor negative, then positive to the capacitor positive. Okay, this is the procedure. Like this you have to connect. Okay, this is the connection. Now you can click on submit. It is correct. Next task, and go to next section. Okay, the next section is understanding physical signals, where will be displayed with a detailed note of the particular category. That is, click on next, and you will be directed to the task. That is, here it is dealing with mechanical system. That is, first you have to use rotational damper element, green color element, and then you have to insert inertia, element, and then you have to include mechanical reference, rotational reference. These things you have to include, and then submit. Here it is showing some error. Okay, that is, it asks us to build a rotational mass damper system. That is, we have to connect. Okay, it asking us to create a system. Therefore, we have to connect and formulate the system. Now submit, correct, and then next. Here now we have to add ideal torque source. Now we have to add ideal torque source block that should be under foundation library. Like this you have to add, and you have to connect the torque to the wheel relative to the fixed ground, that is connect R port to the inertia, okay, and C port to the mechanical rotation reference. So you have to rotate then R to the inertia block and C to the mechanical reference. Now you have to submit. Okay, this ideal torque sensor block from foundation library. Foundation library, mechanical and mechanical source that we have to take. Mechanical sources. Okay, this one, the second one you have to take. How we can place it here, or you can refer the solution also if you have any doubt. Same block. The second block we have to take. Initially we have taken the wrong block. This R should be connected to the inertia block. This is the inertia block, therefore R is connected here, and C should be connected to the reference point, mechanical reference point. This is the mechanical reference. Now submit, and it is correct. And next task, now add PS to constant block. Okay, that is PS constant block. PS this PS constant, that is from foundation library. Once again, this is a constant. Here you have to enter the value of 10 Newton meter. Okay, just type it as 10 in the constant, where the unit should be mentioned, okay, Newton meter instead of 1. Now connect it to the yes. Now submit. It is correct. And next task, and then next section. Okay, the next section is initial values in Simscape. Okay, here also the same. Initially they have the simulation, that is the simulation overview of this particular category with the video. And just click on next. It will be directed to the next section, the description. Once again next, it will be directed to the simulation of this section. First two is the video and then note. The third one is setting initial values. Now you can complete the task. That is, initially you have to open the block parameter dialog box, the rotational damper block, and expand the initial target, whereas you have to expand the rotational velocity. Now remove the target value. Okay, that is check out. They are asking you to uncheck the rotational velocity checkbox, and this removes the target initial value, and then but the information is stored if you check the box again. Okay, now submit. This is the task and it is correct. And then next task, here we have to add gearbox. Okay, gearbox from the same foundation library. If you have any doubt, you can see the solution and then you can connect. There is no issue. Anyhow, you have to do the simulation. Okay, that is the objective. And then here we have to connect the export of the gearbox to the export of the gearbox to the existing inertia block. Okay, here we have to connect like this. You have to connect. This is the actual connection. Export to the existing inertia block and O port to the new inertia block. Here you need to add two inertia. The second inertia block has to be added. Second inertia we have missed. You have to add. You have to include the second inertia block to the model and connect the export to the existing inertia block. We have connected and O port to the new inertia block. Okay, we have connected. Now set the gearbox ratio. Okay, the gear ratio in the gearbox. This is the gearbox where you have to set the gearbox gear ratio, that is, which is already it is 5. Now you have to change it to 2 and set the inertia parameter of the new inertia. This is the new inertia where you have to set the inertia parameter as 0.05. Previously it is 0.01. Now you have to set it to 0.05 kilogram meter squared. And now submit and it is correct. Next task. Now on the inertia block attached to the output shaft, change the priority for the rotational velocity initial target to none. Okay, set the inertia, that is the new inertia block. This is the priority rotational velocity. Okay, here you have to check 2, that is initially it is the priority is high. Okay, in the initial target, here initial priority is high, we have to make it as none. Okay, in the new initial inertia, now it is closed. Now submit, it is correct. And then next task, next is for the future, that is further practice, it is no need. Next section. And then next section, once again the video representation, that is the sixth criteria, the sixth category, under which we have several subcategories. Just let's do the task. The next task, once again notes, go through the notes. And next task, here in this we have to set the values on these blocks. Okay, this rotational damper, this is the rotational damper where you have to set the value of the damping coefficient, which is 10. You have to set it as 10. And then inertia block. Okay, in this inertia block we have to set the value as 1915. We have to set. And then PS constant should be fixed as 50 Newton meter. I have to set these values. It is set to Newton meter and close. Now submit, correct. And the next task, now you have to add a gearbox from foundation library. Once again to the model and branch the inertia block to the input port of the gearbox. Branch port of this gearbox. This like this you have to connect. If you have any clarification, you can see the solution. Just like this you have to connect either upside or downside, anything you can connect. Put a gearbox block and change the gearbox ratio to 0.01. Initially it is 0.5, 0.01 you have to set, close, and then submit, correct. And the next task, now add a rotational electromechanical converter. Rotational electromechanical converter from foundation library. Once again the same structure, you can use this hint block, and to keep the model organized you can help flip and block left right, that is left right you can use by control plus I. Okay, here we need to flip the block, I already told control I you can use. Now you can connect. Okay, there is this R with this O of the gearbox, and set the constant proportionality in the rotational electromechanical converter, that is 0.1 to 0.2 you have to set. Okay, volt second per radians. Now you can sum it. And the next task, now we have to add a second mechanical reference, mechanical rotational reference. Once again you can see the fashion, it should be connected to this element, that is the C port of rotational electromechanical converter block. Now sum it, correct. Then the next box, next task, now we have to add a resistor block. Resistor block we have to add from the foundation library, connected to the positive of, to rotate positive to the positive rotational converter block, and set the resistance. You can use the same, no need to use negative to negative, resistance to 100 ohm, you have to set 100 ohm. Here we have to include electrical reference here to connect this electrical portion. Like this you can connect and sum it. And it is correct. Next task. And next you can use this common equivalent circuit model to represent a battery. So next you have to connect this to the represent a battery, which is a further practice, which is no need, you can direct it to the next section. Next is the notes is given, you can go through this and then click on next, and soon it is directed to the next task, that is the next subcategory, that is fluid domain practice. Here you can do the task. Here you have to add a reservoir IL from isothermal liquid element. Okay, that is under foundation library IL. This one you have to include. Okay, this one you have to include. And second, let me tell you, reservoir VOIR where IL under foundation library under isothermal liquids bar elements. This one you have to select, you have to include, and isothermal properties. Once again you have to include isothermal properties under foundation library under isothermal liquid bar utilities. You have to include these two, you have to include in the model, and then submit, correct. In the next task, and here you have to add pressure source, that is pressure pressure source, which is IL block under foundation library bar isothermal liquid bar sources. Once again this one you have to select and change the source type parameter to the constant. Okay, here the source type, it is initially controlled, you have to make it as constant, where the pressure differential parameter to rho g h, that is we have to type it as r h o asterisk g asterisk h underscore resolution space VA. Have to represent like this. That is the variable this one should be here. We have to connect here, we have to represent instead of 0 you have to represent this one r h o asterisk g asterisk h underscore resolution. So you have to represent here, you have to select PA. A PA you have to select here in the unit section. This is how you have to represent. Okay, this is the representation, and then close and connect A to the reservoir L. Connect A to the reservoir L. Okay, like this you have to connect and connect both the solver configuration. Okay, if you have any doubt, you can see this solution and you can connect. Okay, this is the manner of connection, A to A, and then instead of this you have to connect it here. Okay, this is how you have to connect and submit. Correct. And next task. Now we have to add a pipe, AP pipe, which is IL from foundation library. IL from foundation library, this one you have to add. This one you have to add. And the second reservoir L, second reservoir you have to add. And second from foundation library. And then in the pipe IL, you have to set the pipe length. Just open the pipe where you have to set the pipe length as 20 meter. So instead of the existing value, you have to set it as 20 meter. And then cross sectional area, here you have to set meter squared by default, pi pi, and then asterisk open bracket 0.5 divided by 2 divided by 2 like this you have to type. Now hydraulic diameter is 0.5 meter, to enter like this. This is about the settings. And you have to connect another reservoir here. To just copy, or you can right click on the mouse, it will make a copy, and then you can connect it here. Everything is same. Now submit. It is correct. Next task. Now delete the reservoir at the outlet of this pipe. You have deleted. If you have any clarification, you can see this. See like this. The hint. Once again, you have to make 2 copies of the pipe IL. Okay, like this you have to make copies. You can use Ctrl+C, or you can use right click of your mouse. Okay, like this you can have, and you can connect it like this, in this manner. You have to connect it. Then you have to have the reservoir like this, and now submit. You can click on submit. It is correct, and next task, and you can go to next section. Next is hydroelectric power model. In the last subcategory of this category, sixth one, it is here we have to delete the ideal torque source. Okay, here we have the ideal torque source. We have to delete it. For any clarification, you can see the hint, or you can have clear view of the Simulink picture. You have to delete the ideal source as well as PS constant block from the rotational portion. Like this you have to delete, and add a rotational mechanical converter. Okay, rotational mechanical converter you have to add. Rotational mechanical converter IL under foundation library. This one you have to add. To the model and connect the rotational that is the rotational block of this R and C in place of ideal torque source block. Like this you have to connect R to here. Like this you have to connect, and click on submit. Correct, next task. Next, in the rotational mechanical converter block, set the interface volume displacement value as, here you can just copy and paste, that is very easy. Parameter, here you can paste, which is unit is meter cube, small m, caps, control plus 6. You can use this to have this symbol, exponential symbol. Actually here you have to set, okay, actually here you have to set this value. This has to be set here. It is radians only, here it is 0 only. This is the value. You have to set interface volume displacement, okay, and then submit. Correct, next task. Delete one of the reservoir. It is here in this, they have deleted one of the reservoir block. In this reservoir block you have to delete, and you have to connect it to the A of this rotational mechanical converter, okay, and so delete any one of the solver. Okay, here we have two solver configuration, delete any one. Okay, now you can submit. Okay, the task is completed and correct. Next task and then next section. Okay, this is the next category. The next category will be seen in the next part, the third part. Thank you.